Hi guys, welcome to week 27, day 2. We are again continuing in the Algebra Connections book, which is pictured down at the bottom of this slide. This is lessons 2.1.6 and 2.1.7, the condensed version. So we will go ahead and get started. I'm going to go ahead and zoom in to make sure that you can see everything today. Please feel free to pause me at any time if you need to finish something or if you have any problems and need to review and go back. So we are going towards the process of solving for x using these different variables, using our opposite section, the bottom section of our algebra tile mats. And so we're going to continue to use these legal moves. We talked about those on day 1 of this week. Remember, we have zero pairs, we have remove balance sets, and then we also have to flip, which is like distributing the negative on the bottom. Okay, so we're going to start out by listing exactly what's on top. So if you see on here, you have 1 positive and 4 negatives, 1 plus -4. Then we're going to take the opposite of everything that's on the bottom, which is 1 plus -1. Okay, the opposite of each of those. Then over on the right side, when we start, this is still our original here, we have 3 negatives. Then we have the opposite of everything on the bottom, which is 3 positives. Remember, the transparent ones are negative and the colored in ones are positive. Okay, so these are our original equations or expressions that are representing exactly what is on here first. Personally, I'm going to look and I'm going to start making as many zero pairs as I can. So already I see a zero pair on the top. Okay, and I also see a zero pair on the bottom. So that makes my life a lot easier. That I'm not going to have to flip anything. Because even if I flip it, if I have a negative and a positive and they become a positive and a negative, okay, you're still getting rid of the same thing. So by simplifying, I get rid of this whole section here, okay, and that is gone. Then I'm also taking away 1 of the positives and 3 of the negatives. So I'm still left with -3 over on the left. Then over on the right, I have to do some flipping. So I'm going to flip each one of these up. So these 3 positives are going to become negatives on the top. So I'm left with -6. Remember that if I just looked at this algebraically and I looked at -3 minus 3, I could also write that as -3 plus -3. Which is also -6. That way you can tell that the left side, even though it's a smaller amount, is greater. Okay? Because we have -3 is greater than -6. So to show that and make sure that I am confirming everything about this, I'm going to go to my shapes, to my equation tool, and I thought I had a greater or less than, but I don't. So it is what it is, and we're just going to leave it alone and not even bother. So the left side is greater on here. Sorry about that. So for our legal moves, typically we would only do 1 legal move, but since we're working on both sides, we did zero pairs and flip. Okay? Moving down to letter B. Oh, jump slides on you. Moving down to letter B, where, again, the hardest part of this, honestly, is listing everything for the original. So we're going to start with 1 plus -3 on top. Then we're going to list everything from the bottom. Okay, but we're going to take the opposite of everything on the bottom. So I have +4 minus x. Okay, because that's a -x. I could have written a plus a -x, but I chose to simplify it and just do subtract x. On the right side over here, I have 2 positive plus -1 plus x. Then I'm going to take the opposite of everything on the bottom, which is the opposite of +3. Okay, so my first move here is going to be to flip. I'm going to take all of these things and flip them up to the top and then simplify with my zero pair. So all I'm doing is distributing my negative. Okay, so I'm just looking right here at this distribution of the negative to get rid of any kind of negative symbols that I have, because then it just makes my life a whole lot easier. So instead, I'm going to carry everything down. Normally, I would do zero pairs and all of that too. We're going to wait on that so you can see exactly what's happening with this distribution of the negative. So the opposite of +4 is going to become -4. Then the opposite of -x is going to be +x. Then on the right, after I did my flip and I did the opposite of positive 3, everything else is staying the same, plus -1 plus x minus 3 or plus a -3, okay? Because when I flipped it up to the top, they become 3 more negatives. So now all I'm doing is combine like terms, which is also known as zero pairs. I don't care which way you list it, as long as you know what you're doing. Zero pairs technically refers to when they're algebra tiles, whereas combining like terms is the more proper algebraic name of it. So when we combine this 1 plus -3 plus -4, okay, we're actually taking away one of the negatives by making a zero pair. So 1 plus -3 is going to be -2. -2 plus a -4 is going to be -6 plus x. Then on the right, we have 2 plus a -1, which is 1. And then a 1, skip my x because I'm not combining that with my digits, with my units. We have 1 plus a -3, which is -2 plus x. Then hopefully you see that both sides have that x. So I'm going to remove that x from both sides, that balance set, in order to simplify and be able to compare. Because since we don't know the value of x, we can't accurately tell you what each side is actually greater unless we remove that x value. So now we know that the left side is worth -6 and the right side is worth -2, okay, which is greater. Be careful with those negatives. Just because the digit is bigger does not mean the number is greater. Think about which one is furthest to the right on the number line. That one is greater. Okay, and in order to do that, we removed, balanced, set. So you probably remember when we did this, how we had to list every single legal move. This is kind of just the justification for why is it okay, why is this still balanced, and how is this still working. So we're going to do a couple more practice problems just like this, very, very similar, of just kind of simplifying each of these sides. I wish this was moved up more. Gosh, whoever made this, rude. Didn't center it like I would have, but you know, just kidding. I made it. Let's be honest. My OCD apparently was not on when I was making this. Anyway, so we're just listing our values on here, okay, and then simplifying. I'm actually going to leave the rest of these for you to do, okay? And then I'll come back with the end and I will tell you what the answers are so that you can check your work, okay? So we'll come back to these. And then you have 4 more to do on your own, and I'm going to give you the answers here in just a minute so that you can go back and check your work. But then we're also going to go through together on 258. So we're still simplifying using these legal moves, but we're telling which expression is greater, and we're explaining that. So odds are there's going to be something a little bit different on this one. So on the left, we have 3x's plus 1 plus a -2. Then the opposite on the outside of the parentheses of everything that's on the bottom, which is just a +1 on the left side. Then on the right side, we have x plus 1 plus -3. And then the opposite of everything in the bottom, which is 2, 4, 6. Opposite, not equals. The opposite of +6. Okay, so I'm going to do flip so that I get rid of everything on the bottom and flip it up. So I'm just distributing that negative. So everything stays the same except for the things in the bottom, which become the opposite. So I have 3x plus 1 plus -2 plus a -1, because instead of that +1 here, when we flip it up, it becomes a -1. Then over on the right, we still have our x plus 1 plus -3, but instead of subtracting a +6, we're adding a -6. Then we're going to combine like terms. Okay, so we have no x's to combine over here, so I'm still left with my 3x. Then I have 1 plus a -2, which is -1, and then another -1, which is -3. -2, I'm sorry. The struggle, it's late, sorry. 3x plus negative 2. Then on the right, we have x. 1 plus a negative 3 is negative 2, plus negative 6 is negative 8. Okay? So far, so good. But now we see that there's an x that we can remove balanced sets to remove that x from both sides. And we have 2x, calm down, Siri, 2x plus negative 2 and negative 8. But at this point, can we tell which expression is greater? Can we tell which expression is greater? If we're left with 2x plus negative 2 or negative 8, we cannot tell which expression is greater because we don't know the value for x. So this is kind of like when we did the kite string problem, how if it was under a certain amount, then this person would have more. And if it was above a certain amount, then that person would have more. Then if it was a certain value, then they would have the equal amount of string. So this is where we start to get into solving for equations again. But now all we're doing is adding that element of that opposite box. Okay, so make sure to pause here if you need another minute to explain. This is just another review. We've kind of hit this pretty hard as far as zero pairs. The only thing that was a little bit different that we talked about earlier in problem, I think it was 247 up at the top, was that we can remove a zero pair from the bottom part. Okay, so if there's zero pair down at the bottom, if we flip both of them up, they're going to become a zero pair in the top part as well. So it's okay if we just remove a zero pair from the bottom. That's fine too. Okay. We've already talked about flipping over and over again. If it's positive, it becomes negative. If it's negative, it becomes positive. Okay. We've talked about that. This is the other thing that I want you to see that's similar to combining the flip concept and the zero pairs concept all into one. Removing an equal number of identical tiles from each of the sections. So they removed 2 negative tiles and then 2 negative tiles from down here. Remember, this is the opposite of 2 negative tiles. So this is actually 2 positive tiles. So if you remove the same amount from the top and the bottom, you're actually removing zero pairs. It just takes one step as opposed to flipping it up to the top and then creating those zero pairs. Okay, I just wanted you to see that example here. So again, we are solving and simplifying exactly what's going on here as far as these expressions. So we're going to simplify by copying these down. 3x, the opposite of 2 minus x. Notice how I said the opposite of, because that would go in the bottom section of your algebra tile mat if you're building this. Okay, whereas you would have a 3x and a unit up top. They're just not listing everything on the top first and then the bottom part. Okay, and then the right has negative 5 plus 4x plus 4. Okay, my first thing is I'm going to flip because I want to get rid of my parentheses. Think about with order of operations, you want to get rid of your parentheses as long as it doesn't mean separate. Okay, so like if I had parentheses right here around my negative 5 to show that that was one term, that wouldn't necessarily mean do first. But because I have this negative on the outside of the parentheses, I have to distribute that or flip my tiles to the top. So I'm going to have 3x distribute my negative to my 2, which becomes adding a negative 2, and then distribute my negative to my negative x, which becomes a positive x plus 1. I didn't have to do any distribution over on the right, so I'm just going to bring it down so that it's still balanced. So I have negative 5 plus 4x plus 4. Okay, then I see over on the right side I have some zero pairs, and then also on the left side I have some zero pairs, and I'm going to combine those. So I have 4x minus 1, or plus a negative 1 if you'd rather. And then on the right side I have negative 5 plus 4, which is negative 1, plus 4x. Okay, what do you notice about these? Hopefully, it's that they're equal. Okay. So which is greater? They are equal. Okay, we're going to go through and do B together as well because I don't want you to get confused just because there is a 2x squared. Remember, that's just the label of another tile. That's all it is. Okay, so don't get confused because it has that squared. So we have 2x. Remember, control period makes it the squared button, and then control period makes it go back down the way you wanted it. Plus 2x plus, oops, now look, see, now you got me all messed up in my spaces. Minus, so the opposite of negative 3x, or the opposite of 3 minus 2x squared. Oh, that's supposed to be a parentheses, not an asterisk. Sorry. It's late. Sorry, y'all. This is why I don't do math late, because I don't know what I'm doing and I look ridiculous. Okay, why are we not going down? Control period. Thank you. Plus 5 plus 2x. Okay, first thing I want to do is my flip. Flippy. Just kidding. It's late. And so everything over here is just being brought down, but then instead of the opposite of negative 3x, I'm going to add 3x. Then on the right, I do have to distribute that negative. So I have negative 3 plus 2x squared. Because if it's the opposite, instead of that opposite of negative 2x squared, I'm going to take positive 2x squared. And then I just got lazy, so I did copy and paste. Sorry, y'all. Okay, then I'm going to combine my like terms. So when I combine my like terms, remember that 2x squared is not the same. It does not combine with 2x's. Those are different. Okay, so I have my 2x squared plus 2x. Notice how they're in descending order again. Plus negative 3 plus 5 is going to be 2 on the right side. Then on the left side, I still have my 2x squared. But then I have to combine my x's. I have negative 2x and I have a 3x. So I'm going to add 1 plus 6. I forgot my little x label. See, this is why you got a label. Okay, I can remove balanced sets. Remember, we want to get this as simplified as possible before we make a decision here. So I'm going to subtract my 2x squareds. And again, I'm lazy, so I'm just copying these. I'm going to subtract my 2x squareds because I can remove that from both sides. And then I also see that I can subtract an x. Why is this being difficult? I can subtract an x from both sides. Okay. And then I can also subtract 2 from both sides. So I could have absolutely done that in multiple steps. As long as I'm removing the same amount from here, then I am totally fine. I'm going to add another row, insert row below, because I didn't put enough on here to have the simplified form. If I subtract 2x squared over here, those are gone. I have 1x, I subtracted that, that's gone. So on the left, I'm only left with 4 units because I had 6 and I took away 2. On the right side, I had 2x squared, took away that 2x squared, so that's gone. I have 2x, so I subtracted an x. So I'm left with x. And then 2 minus 2 is 0. So I still cannot tell which is greater. Normally, this would be great because if we had an equal sign here, we would know what exactly would need to be for x in order to balance these expressions. But in this case, it's asking which is greater. We can't tell, okay? If we have a 4 on one side and an x on the other side, we don't know what the value of x is. to be able to differentiate between which is actually going to make it greater and which is not. Okay? Moving on. Hopefully you're sticking with me. Good old Athena was comparing expressions shown at the right. She was called out of the classroom. When her teammates needed help, they looked at her paper, saw the work she had below, and unfortunately, she forgot to explain her simplification. Naughty, naughty Athena. Can you figure out what Athena did to get each new set of tiles? Okay, so what we're doing here is we're trying to figure out what did she do each step. Okay, so we went from 3x plus 4 minus x, the opposite of negative 2, plus x squared. And then we have negative 1 plus x squared plus 4x, the opposite of 4 plus 2x. So it looks like she took away that x squared. So her first step is to remove balanced sets, which was to remove x squared. Okay, the first step she did was to remove x squared. So then she was on this second row, and she has 3x plus 4 minus x minus, take one the opposite of negative 2, and somehow she got rid of those parentheses. That's the first thing that sticks out to me here. And so if I'm distributing that negative 2, then I'm actually going to have a positive 2, which is exactly what happened. So if I check that over here and I see that she distributed that negative to everything in the parentheses, then I know she for sure flipped, aka distributed the negative. Okay? She absolutely distributed her negative there. Then she got from this big long expression, 3x plus 4 minus x plus 2, down to 2x plus 6. And negative 1 plus 4x minus 4 minus 2x got it down to 2x plus negative 5, or 2x minus 5. So we know with that part, she combined her like terms. Okay, she took all of her x's total and got a total of 2x, and took all of her units in total to get her 2x plus 6 and 2x minus 5. Combined? Did I not spell combined right? Is it that late? No, it did combined. Didn't like my grammar. Or like your face. That's where we're at, y'all. Okay, so then to get to that last step, she removed balanced sets again because she removed 2x to decide that 6 was greater than negative 5, so the left side is greater. Way to go, Athena. See, this is what you all get for copying, because if you would have just listened to what Athena said before she left the room and she didn't work ahead, we could have worked as a team. Just saying. All right, problem 267. Here we go. For each pair of expressions, determine which is greater by carefully recording your steps. Similar, exact same process. We're just literally listing, but now we have some other crazy tiles. Okay, so we have x squared plus a negative, and I'm going to copy this x squared because it takes me too long to type it, plus a negative x squared. Oh my gosh. Don't know why we're being sensitive right now. X squared plus a negative x squared plus 2x on the top. Then the opposite of what's on the bottom, which is an x squared, not 2x squared. I don't know why it keeps doing that. And that's positive on the bottom. Lordy me, I can't type to save my life. And now we're not going to go down. That's what we're doing now. Okay, that's what we're doing. Haha. And that actually needs to be together. Okay, see, this is what's happening. Plus 1. Oh my gosh. Plus 1 minus 1. Oh, that was way too much of a struggle. Okay, then on the right, we have x plus 3 plus negative 1. Then subtract the quantity of x squared plus 1. Okay, first thing I'm going to do is I'm going to flip. I'm going to get rid of that negative, that distribution over here. And with that 1 and that -1, I'm going to go ahead and just take those out because I don't need that for the bottom. So I'm going to have everything just the same without that 0 pair. And instead of the negative on the outside of the parentheses, I'm going to flip that positive to make it a negative x squared. Then on the right, I'm doing the same thing. Everything on top stays exactly the same. But then I'm going to distribute, and I'm going to have the opposite of x squared -1 instead of +1 because we're taking the opposite here. Okay, so I flipped all my tiles up to the top. Then I'm going to combine my like terms. So I see that I have 0 pair here. So I'm left with 2x minus x squared. And on the right, I'm going to combine. I have no x's to combine with, so I'm going to leave him alone. Then I have a 3 and a -1, so that's going to become 2. And another -1, which is going to become 1. So I have a negative x squared plus x plus 1. Okay, so all I did here was I combined my like terms. And if it's asking which is greater, there's nothing else that we can remove besides an x from each side. And even then, it's not going to simplify it enough. So we can't tell. Without knowing the value of x, we have a negative x squared. Okay, I'm stupid. I know, story of my life. They're both negative x squareds. So we're gonna add an x squared to both sides, which is gonna make this. I knew it wouldn't turn out like that. Oh my God. This is why I don't do math late. Okay, plus x squared. And then we're also going to remove an x. But of course, I didn't go down. I hate these little squared things. I hate them. I hate them. So I'm going to remove an x from both sides. Remove, balanced, sets. So I'm left with just x on the left, and I'm left with just 1 on the right. So again, we still can't tell. But again, if we were solving, even though we saw these x squareds and this craziness, we could figure out what value would make them equivalent. Okay, you have 2 more to do on your own here. And in a minute, I'm going to show you the answer so that you can check your work and ensure that you're getting them correct. But you need to go back and finish 267 on your own. Then your homework for tonight is you have 3 problems. You're simplifying these expressions. Then, oh, look at this proportional reasoning problem. Oh, and some percents. Look at that. Doesn't that sound fun? I knew it did. 269, last one. You are showing, are her moves legal? What did she do and why? And are they legal? Okay, so that's what you're explaining. That's everything for this week. And now I'm going to go through the answers. Okay, so real quick, I'm going to go over the answers to 257C, in which case the left side is greater. You do have to show the work. There's 2 steps that you have to show in order to get there. But if you need to, go ahead and pause and double check to make sure that you got these problems written down correctly. Then for D, make sure that you got the problems written down correctly, but the right side is greater. So make sure you show that work and the legal moves that go with it. I'm not showing you my work because you actually have to solve these problems. I just want to make sure you're on the right track. So then for 257, for E, When you solve that, they actually are equal on both sides. Okay, so they simplify to the same thing on both sides. And then for F, the right side is greater, even though we got all this mumbo jumbo. Okay, so if you have any questions, remember that I have extra math help on Thursday. I also have office hours on Wednesday and Friday. Be sure to come and join those. And the last two that I wanted to go over the answers for are 267, where you can't tell for B, which is greater because of the way it simplifies. You've got to show me that. But the answer is that you can't tell. And then for C, the left side ends up being greater. So again, if you want to show your work here, you have to in order to get full credit, FYI. Okay. And then if you have questions, comments, concerns, please come see me in my office hours or any of the extra opportunities here. So that is all I have for you today. Congratulations. The end.